Okie doke. So we have 3 new identities, and actually there are 6 identities because we're using plus or minus or plus to encapsulate 2 identities in one. So we have that the sine of the sum of 2 angles is the sine of the first, cosine of the second, and the sines in the middle are the same. Then the cosine of the first, sine of the second. If we have the sign of a difference, the difference carries on. It's going to be the same sign in the middle for sines. And then for cosine, do you see that the sign in the middle is always different? If we have the cosine of a sum, the sign SIGN in the middle is a negative. We have the cosine of a difference, the SIGN in the middle is a positive. Cosine of the sum of 2 angles is cosine of the first, cosine of the second, minus sine of the first, sine of the second. And then finally, we have tangent of the sum and difference. And you can get to the tangent formula by dividing sine of the sum or difference by cosine of the sum or difference. The proof of these identities, we're only going to look at in a cursory way. Oh, I did want to include some information in our notes. With respect to, Z with a double bar is the set of all integers. Epsilon, or that Greek E, means in or contained in. The upside down A means for all. The R with a double bar means the set of all reals. I think those are all of the symbols, notations that we've used so far. If you can think of another one, tell me and I'll put it in here. And then we've got some processes that we think of, but we don't always think of their reverse. So if we can add 2 fractions that have a common denominator, then if we've got the sum of 2 things in the numerator and 1 denominator, we can unadd. We can write A plus B all divided by C as A over C plus B over C. Squaring and multiplying conjugates, that's expanding a binomial. Binomial means 2 terms. Factoring is the opposite of expanding. And this is a pattern I want you to see. A squared plus 2AB plus B squared is A plus B all squared. And the sign in the middle matches. So it's A squared plus 2AB plus B squared. That's A plus B squared. And then the difference of 2 squares is the same as multiplying conjugates. I almost always put the A minus B factor first because minus signs tend to get the second, I don't know, they're overlooked. Plus signs always come first. So I tend to do it the other way. I did one somewhat different thing in these notes, and that is that I included the solution. But so say we want to find the exact value of something horrible looking. Let's first just notice that we've got to repeat. This 25 pi over 24 appears twice. 17 pi over 24 appears twice. So we're just going to pretend that we're complete idiots. We're going to let alpha be 25 pi over 24, and beta be 17 pi over 24. And using alpha and beta, this pattern is cosine alpha, cosine beta, minus sine alpha, sine beta. And which of the identities fits this pattern?
Cosine difference A and beta. I don't know how to say it right now.
It'll be the sum. Yeah, because cosine is always opposite. So the cosine of a sum has a negative in the middle. Cosine of a difference has a plus in the middle. But yes, very good. So we've got, this is equal to cosine of alpha plus beta. And now I can just find alpha plus beta. So alpha plus beta is 25 pi over 24 plus 17 pi over 24. Let's see, what is that? 42, is that right? $25 plus 17 is 42.
Yep.
Thanks. Okay, good. And let's see. 8 doesn't go into both. 4 doesn't go into both. Does 6 go into both?
Yes.
Yes. 6 goes into 42. How many times?
7
7
times.
times.
Good. And 6 goes into 24.
4 times.
Beautiful. So now alpha plus beta is just 7 pi over 4. Is this angle between 0 and 2 pi?
Yes.
So it's in the unit circle. It's in our regular unit circle. Does cosine have positive coordinates or negative coordinates in quadrant 4?
Sorry, could you say that one more time?
Sure. Does cosine have a positive coordinate or a negative coordinate in quadrant 4?
Positive.
Cosine is
Good.
positive.
That's right. And this is 7 pi over 4. 4 is the denominator, and we can't reduce it. 7 and 4 don't have any factors in common. So I know that this is going to be just like pi over 4, which is square root of 2 over 2, square root of 2 over 2, with a correction for the SIG ends, the signs in quadrant 4. So what are the coordinates of the point at 7 pi over 4 in quadrant 4?
Sorry, could you say that one more time?
Sure. We know that the coordinates of pi over 4 in quadrant 1 are square root of 2 over 2, comma, square root of 2 over 2. How do we need to change those to fit in quadrant 4?
Just change the signs, right?
That's right. So we have positive square root of 2 over 2, comma, negative square root of 2 over 2. And that means that the cosine is?
The cosine is square root 2 over 2.
Very good. So we said that we were trying to find the cosine of alpha plus beta, and we showed that alpha plus beta was just 7 pi over 4. This is the cosine of 7 pi over 4, and that is just square root of 2 over 2. I think I want y'all to do this next one. Wow, I made a mistake in the notes. So what we just did was correct. So I'll correct the notes. I want y'all to try this one. And I want to hear you. Excellent. So yes, the angle was 2 pi over 3. The sine is square root of 3 over 2. So these properties allow us to take angles that we do not know sines and cosines of, but find the sum or the difference of some product exactly. Let's do something else. Let's look at the sine of 3 pi over 2 minus x. And for this one, I want to think of this as the sine of alpha minus beta. What is taking the place of alpha and what is taking the place of beta? If I write 3 pi over 2 minus x as alpha minus beta, what is alpha and what is beta?
So your alpha is going to be 3 pi over 2, and your beta is going to be x.
Very good. And I know that the sine of a difference is sine of the first, cosine of the second, minus cosine of the first, sine of the second. So let's see. Sine alpha, cosine beta, minus cosine alpha, sine beta. Gosh, I don't see how this is helping us, but let's go ahead. We said that alpha was 3 pi over 2. So we have the sine of 3 pi over 2 cosine x minus the cosine of 3 pi over 2 sine x. And where is 3 pi over 2? Good.
On the very bottom.
So, yes, very good. So the coordinates of 3 pi over 2 on the unit circle are 0, -1. Which one goes with sine and which one goes with cosine?
Cosine goes x, sine goes with y.
Very good. So cosine, let me find a different color. The cosine of 3 pi over 2 is 0. And the sine of 3 pi over 2 is -1. Okay, that's kind of helpful. Let's see where we are. So we have -1 times the cosine of x minus 0. And can I just write that as negative cosine x?
Could you say that one more time?
Can I write -1 times the cosine of x as negative cosine x?
Oh, yeah, yeah.
Okay, great. So we've got that the sine of 3 pi over 2 minus x is equal to negative cosine x. Which sign, where did this negative in the middle show up in the formula?
Like in between like the cosine, sine, and stuff like that.
Good. And what did we notice about the second term? What was its value?
The value of 3 pi over 2, or was it
The value of the whole second term, cosine 3 pi over 2 times sine x.
so 0 times sine x would it be
Is
0?
0. Yes.
Yeah.
So in other words, regardless of this sign in the middle, the sine of 3 pi over 2 plus or minus x is going to be negative cosine x, because the second term is the only place where the negative sign or the positive sign shows up, and the second term was all 0. So let's walk through the next one together. Let's see if we can simplify cosine of 3 pi plus x. So we've got cosine of 3 pi plus x. And what is the formula for the cosine of a sum?
Isn't it so it's cosine alpha, cosine beta with the opposite sign, sine. Did it
Okay,
say sine,
good.
sine times sine?
Yeah, that's right. So we've got cosine 3 pi cosine x. This sign in the middle is opposite for cosine. So minus sine of 3 pi sine x. Is that right?
Yeah, yeah. It looks
And where on the unit circle is 3 pi?
if 2 pi is that one side, just do another pi.
Oh, okay. So the point -1, 0.
Yes.
Excellent. So at 3 pi, we have the point -1, 0. Which one is cosine and which one is sine?
Cosine is x and sine is y.
Okay, awesome. So we've got that the cosine of 3 pi is -1. The sine of 3 pi is 0. So we get this a similar outcome, but it's interesting. We get that the cosine of 3 pi plus x will be negative cosine x. These next, this next example is really important. So I know that y'all are working on homework and stuff. Try to pay attention for this one example. When you're trying to find the exact value of the sine or the cosine of the sum of two angles, and you're given the sine of one and the cosine of another, you want to figure out where alpha and beta are and draw triangles in the correct quadrants. You want to use the Pythagorean theorem to fill in missing sides, and then find the sine and cosine for each triangle. So let's see. If we're given that we want to find the cosine of alpha plus beta, we're given that the sine of alpha is -12/13, and alpha is in quadrant 4. We know that the cosine of beta is -8/17, and that beta is in quadrant 3. The quadrant tells me where I want to draw the triangle. So let's start with alpha. If I know that the sine is -12/13, what sides of this triangle can I label?
The opposite.
Good. Opposite and
Hypotenuse.
okay, good. So we've got -12 and 13. And let's always use the convention that the horizontal side is A, that the vertical sides go with B. How can we figure out what little a is?
Using the Pythagorean theorem.
Good. So we know that a squared plus -12 squared is 13 squared. And 169 minus 144.
Is it 25?
Good. So if a squared is 25, and we take the square root of both sides to get to a, what do I need to throw in here at this step?
Plus or minus.
Very good. And now I can leave it off. So I know that in quadrant 4, a is positive or negative.
Positive.
Good. So we get 5. And do you see that now that we've got all 3 sides of this triangle labeled, it's easy to write the sine and the cosine of alpha. Let's do the same thing with beta. We said that beta was in quadrant 3. We're given that the cosine of beta is -8/17. How can I label the sides of this triangle if I know that the cosine is -8/17?
adjacent over hypotenuse.
Very good. So we know -8, 17, and call this little b. How did I know that the negative went with the horizontal side and not the hypotenuse?
Hypotenuse always stays positive.
Very good. Very, very good. So let's see. And how can I find little b?
Forget. Can speak this morning.
Good. Good. So we've got -8 squared plus b squared equals 17 squared. 17 is 189, 289, 189. And 8 squared is 64. So we have 189 minus 64 is b squared. Oh, it must be 289. 2, because b has to be 15. Okay, so we've got that b squared is 225. What do I need to do at this step?
Square root it, and
Okay.
not forget the plus or minus.
Excellent. And in quadrant 3, is b positive or negative?
Negative.
Good. And again, for beta, triangle beta, we've got all 3 sides. So we've got all 3 sides for both triangles. And let's see what they were wanting us to find. They want we want to find the exact value of the cosine of the sum. So let's see. We know that cosine of alpha plus beta, cosine, that's the one where the signs in the middle are opposite. So we have cosine alpha plus beta is cosine alpha, cosine beta minus sine alpha, sine beta. But we've got these nice triangles. So we know easily the sine and the cosine of alpha, the sine and the cosine of beta. So we've got cosine alpha, sine alpha, cosine beta, sine beta. And what is the cosine of alpha? What over what?
Five over 13.
Good, thanks. The sine of alpha, let's pretend that we weren't given it in the beginning. Is it easy to read off of the triangle?
Yeah.
Cosine of beta?
-8 over 17.
And the sine of beta?
-15 over 17.
Okay, excellent. And we are putting in the cosines together and the sines together. Let's see. 5/13 -8/17. And then we've got -12/13. And -15/17. And I noticed something looking at these numbers before multiplying them out. 13 times 17, 13 is a prime number, 17 is a prime number, and neither 8 nor 5 reduces them. Neither 12 nor 15 reduces them. So I'm going to leave 13 times 17 as the product of two numbers. Eight times 5 is
40.
and we have a negative times a negative times a negative. So we're left with
Negative.
good. And 12 times 15. Oh, 3. $180. So it looks like the numerator is -220, and the denominator is 13 times 17. I like this kind of question because there's no way that you would accidentally come up with this a different way and get it correct. But it's not hard. It's just sort of a headache. So, and it looks like for the final answer, I did actually find the product of 13 and 17, which is 221. I do want y'all to do the try this 3. And then we're gonna, oh, I think we're doing fine time-wise. So I want y'all to do the try this 3. It's super important that you know how to deal with these questions where you need to draw triangles.